Our next chapter in our workbook is chapter 9. It's all about waves and the characteristics of waves. So a wave, right here, a wave is a disturbance that moves through matter or through empty space. Waves do not carry matter, they carry energy from one place to another. When a wave moves, it can tell us a few different things, and there's a couple different types of waves that we're going to study. These notes that we're going to do today are going to talk all about transverse waves. So transverse waves, the way that you can think about this is that if we pay attention to the wave direction, which I have written right here, we draw a line up to its highest point in the direction that it's going, it makes a T, like you kind of see in the background. And so a wave moves up and down, but as it moves up and down, it travels right to left. That is a transverse wave. The particles, as the wave moves left to right, the particles move up and down. So in a transverse wave, there are vibrations of particles of matter that are moving back and forth at right angles to the direction that the wave is moving. So if the wave is moving left to right, the particles move up and down. So in a transverse wave, the wave moves left to right, and the particles move up and down. There are some different properties of transverse waves that we use to describe them and how they're moving. First is amplitude. So the amplitude of a transverse wave is the total distance that the wave moves or oscillates from its resting position. So amplitude is how far did it go from the resting position, or where it would be if there was no energy traveling through it. So this distance right here. You could think about this like that it's making an A for amplitude. So the amplitude is how high above the resting position, or how low from the resting position did it go. So what is this distance from the resting position, so where it would be if there was no energy going through it, to the peak or the farthest point from the resting position. Another property is called the crest. The crest is the peak or the highest point in a wave. So it's wherever the highest point of the wave is, that is the crest. So a crest of a wave is when the wave gets to its highest point in water. If you live in a city that is frequently floods or by rivers, they talk about, well, the crest is going to be reached at this time. That's when the river gets to its highest point. So crest is a highest point on the wave. A trough is the lowest point on a wave. Where is the wave at the lowest? And you can think about this if you kind of trace that. Kind of looks like a trough. If you feed animals, if you have livestock, you put water or food into a trough, it's what they eat out of. And so trough is the lowest point. Another property that we measure is called the wavelength. So the wavelength is the distance from any one point on a wave to a corresponding point on the next wave. So how far does it take to get from one point onto the wave to that same point on the next wave? So if we want to go from this point right here, how long does it take to get to that same point on the next wave? How long is the wave? And this is called the wavelength. It's really just saying how long is our wave. Another characteristic of a transverse wave is its frequency. So how frequently is the wave going? Frequency is the number of oscillations produced in a certain amount of time. So how many waves are passing. So if we want to figure out what the frequency of this wave is, we would see how long does it take for the wave in a given distance or given time, how many waves pass. So if we say that this line that is drawn is 1 second, how many waves get from the beginning to the end in 1 second? We have the red one is 1 wave, 2, 3, 4. And the only reason I have them being different colors is that it's easy to determine that they are, where one wave ends and the next one begins. It's all one big transverse wave, but how many oscillations do we see? So each different color that's on there is an oscillation. It's kind of like if you stood on the shores of a lake and you counted in 30 seconds how many waves hit your feet. You would be measuring the frequency of the waves. How many hit your feet in 30 seconds. That's the frequency. And so this wave that's drawn here that I drew has a frequency of 4 hertz because it has 4 waves, 4 oscillations in 1 second. 1 hertz is a wave per second. So there's 4 waves that occur in that 1 second. Another property is wave speed, and we've dealt with speed before, so we understand that speed is distance that a wave travels in a given amount of time. And this is measured in meters per second. So remember with distance, we always take, to find speed, we always take distance divided by time. So if a wave travels 6 meters in 3 seconds, the speed is 2 meters per second. If a wave travels 10 meters in 2 seconds, the speed is 5 meters per second. So wave speed is just saying how far did the wave go in a given amount of time. So kind of in summary, what is the amplitude of the waves below? Well, to find amplitude, we are going to find our A. So how high above the resting position or how far from the resting position did it get? Well, our distance right here says 0.5 meters. That is our amplitude. What is the wavelength? So how long does it take to get from one point on the wave to the same point on the next wave? Well, I have here to that same point is 2 meters. How many full waves are shown? Well, if I go from this beginning to its end, that's 1. Beginning to the end, that's 2. So there's 2 full waves. How many waves are generated in 2 seconds? So the total time on this one is 2 seconds. So how many waves did we count that happen in that 2 seconds is 2. The speed, well, our total speed right here says 4 meters. So we take 4 meters divided by our time, which is 2. So the speed is 2 meters per second. Then it asks us to label one crest, and crest is the highest point, and one trough, and a trough is the lowest point. Remember, trough is going to be like your animals are eating out of it. Crest is like the point of the mountain. So there we have it. These are all characteristics of a transverse wave. Transverse waves, so waves that move side to side as their particles move up and down.